Okay, we're all good. Two more examples we're going to look at. A short one and then a lengthier one, and that should do it for today. I would like you to read 8. I'd like you to store the functions in the calculator, but don't do anything else. Read it and store them in the calculator. And this is different because there are now 2 functions. And they love questions with 2 different functions like this. So one of them's going in y1, the other's going in y2. Okay. How many people, so let's see, T is the hours since the fair opened. We know how many people were at the fair in the beginning. I think I need to factor that in here. I'm going to start with those 200 people. Not at the beginning, at the end of the first hour, but that will work. How many more people have entered the park?
EFT.
No, not EFT. Integral of EFT. Now, from what to what? I'm not going to start at 0, I'm going to start at 1 because you knew the people at time 1. If you add the integral, we will get the total number of people who have now entered the park. Is this the number of people in the park?
No.
Why not? The problem is people have left. How many people? Well, we can integrate the rate that people are leaving. And don't go to the calculator yet because I'm going to show you a quicker way we can do this. Starting number of people, total number of people who've entered, minus total number of people who've left. And they really like these questions with 2 different rates, a rate in versus a rate out. We'll see a bunch more examples of that in a moment. Now, I can simplify this a little bit. Kevin. Exactly. Because the limits of integration are the same, how about I just do one integral over here? The integral from 1 to 3 of the rate in minus the rate out. And honestly, this is kind of like the rate of change of the people in general. So you integrate that, you get the total change in people.
You started the integral from 0, you did not have to add 2.
The problem is you don't know how many people were there right at the start, right at time 0. So we really can't do that. We've got to factor in the starting amount, and we only know the starting amount at time 1. So go and figure things out here. And I think you don't even have to round. I think it just works out nicely. By the way, this could, in theory, have been a non-calculator question because these are easy enough to find the integral of. We are going to do this whole unit with the calculators because I don't have the time for you to do those things. But if the functions are easy enough, yeah, you could be expected to find an antiderivative and plug in some values. I'm sorry, I don't like broccoli. What's the answer? 42? No, 482. Is that what you said, John? 480? I didn't hear the middle number in the middle. 482 people. I have one more thing we're going to look at that uses this idea of those 2 rates, a rate in, a rate out, but goes in a bunch of directions. This was on an AP exam, but I adapted it a little bit to throw a few other variations in there. And if we can get through 9, that will be all we're doing today. And then that's it. Take a moment, read 9, store the functions in your calculator, and I'd like to see if you can do part A. Store them in there. You need y1. And I know I've said this before, but I need to keep reminding you of this. When you're writing things out, make sure you're not writing using calculator notation. No y1 and y2. Use the functions they gave you. Use normal like math notation here. E of t, L of t. Inside the integral, you're going to say for instead of y1 comma x, you're going to say y1 minus y2 comma x comma 0 comma 1 comma 3. Store those things in the calculator, please, for number 9.
So there was a time where the net change was negative, but how does that know?
I think I don't really want to answer that yet because I feel like as we work through the next few examples, they may kind of answer that question. I also, though, feel like in this problem, if you were to graph both of those rates, you would see that, I think, they're always positive when your time is positive, which would make sense. You can't have a negative rate that people are entering the park, or a negative rate that... So yeah, those functions were created, so both of those rates are positive. And honestly, the problem you're asking about that had a negative rate, it was kind of like there was a rate in and a rate up, but they already did the work for you to combine them into one function that just gave us our overall net change, our rate of change. So again, once you've stored them in, please try to do part A. How many people have entered the park by 5 p.m.? Do you care about E of t? Do you care about L of t? I'm not asking you how many people are in the park. How many people have gone through like the ticket booth by 5 p.m.? We don't care about people who have left. So what are you going to do? What's your starting time? 9 a.m. is t equals 9 because it's hours after midnight. 217 of E of t dt. The directions say round to the nearest whole number, so please do round. And again, this is not how many people are in the park. This is how many have gone through the ticket booth by then. 6,004? I think so. Problem, Brady?
Somehow a square got into my equation.
Nope, don't square it.
I didn't even put it there.
I'd like to see if you can do part B, which also has nothing to do with the people leaving the park, just the people who have entered. See what you can do in B. Yeah, you gotta type in the function correctly. It does change things if you don't. We're doing part B, I hope. Are you doing average value of E or average rate of change of E? Yeah. We have the rate people are entering the park. I'm going to know the average rate people are entering the park, average value. What numbers, though, are you using? 1 and 10?
You technically can
For out front, but not for the limits of integration. So we should be consistent there. We should use 13, and we should, what's the other one? 22. You're going to do 1 over 22 minus 13 times the integral from 13 to 22 of E of t dt. Get a decimal, that's fine, and put units on it. And again, I'd ignore the 1 over 22 minus 13. I'd just do the integral, then divide it, just so you're not having a typing in issue. Drew, what are you getting?
409. 410.
So decimals are okay here because it's a rate anyhow. So 409 point. Good. And what kind of units? People per hour. Because those are just the units of E of t. Yep, people per hour. Turn the page. Questions before we go on, though? Turn the page. Create a function defined by an integral to predict the number of people in the park at any given time. Okay. What was that? Okay, so I want to create a function that's not going to find the number of people in the park at time 10, but at time 10, time 13, time anything I want. H of t equals. Was there a starting number of people?
0 at hour 9.
There was no one in the park. Of course, there was no one in the park by the time they're opening. So we're starting from, we don't need to include in anything. What? If there was a starting amount, we would include that. Then I'm going to do an integral. 9, well, not really to x, but to t. Inside the integral, do I want one function or both functions? I don't care about the number of entered, I care about total number of people in the park. So yeah, E minus L. Now, I probably shouldn't, this is just a notation thing, but I probably shouldn't call it E of t and L of t, only because then I'm using t in two different contexts over here. So I'm just going to change the variable inside. This is not really a big deal. But the idea is, if we were able to do this by hand, we'd find the antiderivative of that. You get something with x in it, and then plug in t minus plug in 9. It's kind of weird to integrate something with t's, then plug in t where t was. It's just a notation thing. No, they wouldn't take off, but it's better to write it like this. I'm using it in two different contexts, though. T is the specific time I want to know how many people are in the park. It wouldn't make sense to say that that thing is the same as the variable inside there. 6 p.m. I'm going to... 18 hours, so it's like I'm trying to find h of 18. Which means I'm going to find the integral from 9 to 18 of, well, just what we had over there. And you know what, since I no longer have a t, I have a number there, I suppose I can go back to t's. You can leave it as x's. It doesn't really matter. But let's get a number. And you're going to round. I just changed it back. Don't. Leave it as x's, you're fine. How many people? 3186? No, Maggie? Do I need to take a look at how you're typing in? You okay? I want to do one more part of this. We'll save F for next time. But if we can get through E, then we'll be right where the other class ended. Anything so far in D? Final piece. Well, not final piece for today. H prime of 18. I know h of t is the integral from 9 to t of e of x minus L of x. And I want to find the derivative of that. This is what I meant when I said these problems pull in a whole bunch of ideas. How do we do the derivative of a function defined by an integral? Exactly, second fundamental theorem of calculus, which says do what? The derivative and integral cancel. I'm just going to plug in the t where the x was, and I'm going to get the formula e of t minus L of t. So to find h prime of 18, fn int or n deriv on the calculator? Or neither? Neither at all. Plug in, you're going to do your e of 18 minus L of 18. Let's get a number, and then we'll need to figure out what's the point. Then it's like you plug in the t where the t was. That's another reason I changed it to x's, just because it looks kind of weird to plug in t where t is. Answer?
Negative 689 people per hour.
Yes. I might as well add that in.
Why is h5 of t just t of 2 minus L?
I'm trying to find the derivative of my function defined by an integral. The second fundamental theorem of calculus says the derivative and integral cancel, and we just get the stuff that was inside the integral with the t plugged in. That's our second fundamental theorem of calculus. Eliza.
Would you do that as like doing like y1 18?
Exactly. y1 18 minus y2 18.
So you don't have to do the integral itself.
I don't see an integral in the problem. You shouldn't be doing an integral. Last thing, though, we need to interpret this. When you interpret things, you need to make sure you refer to the time we're dealing with. So at t equals 18. Or you could also say at 6 p.m. What did I find?
Well, the net total of people.
Okay, there are two ways we can talk about this. This integral gives you the total number of people in the park, right? So the derivative is the rate of change. So at t equals 18, the rate of change of the number of people in the park is negative 689 people per hour. That is one way we can interpret this. But there's maybe a better way. Oops. And actually, I don't like what you said, John, because this isn't about people leaving the park. It's about the change in people, because there was something else for leaving the park.
I would say like the net total of people decreased by 689.
Okay, so first of all, again, I'm going to refer to t equals 18. How about the number of people in the park? That integral gave you the number of people. Its derivative is the rate of change of the number of people. So I can say that the number of people in the park is decreasing at a rate of negative 689.
No, positive 689.
We accounted for the decreasing with the language, so I don't need to include it again, otherwise decreasing by a negative really means increasing. People per hour. I think that second version is probably the better explanation, but either of them would have been okay. At t equals 18, the rate of change of the number of people in the park is negative 689 people per hour. It kind of seems weird, though, to say a rate is negative. Better to say the number of people in the park decreasing at a rate of that. Nathan.
Why did we ever use instead of 0 people?
That's kind of how I created my function over here. If there were 20 people already in the park, I would have had to say 20 plus that integral over there. The starting amount plus the change in the number of people. But because we were starting with 0, we didn't have to include something there. We'll see other problems tomorrow where there is a starting amount in a tank or something. We'll include that with our integral. We're going to save that for tomorrow. By the way, just very quickly, part F. When is there a maximum? When f prime, but that's for a relative maximum. I want to find like the absolute most number of people. Oh, yeah, that's going to take some time. We'll save that part for tomorrow. Couple things.